In this lesson, we're going to once again use the formula we saw in the last lesson to find the angle between two vectors. So up here in the upper right-hand corner, let's remind ourselves how to find the angle between two vectors. That formula was cosine of theta equals the dot product of u and v divided by the magnitudes of each multiplied together. Now we're going to be using this formula to accomplish several objectives, but to get started, we'll do one more example of finding the angle between vectors, and then we'll move on to some other objectives. All right, so in example 1, it says graph the vectors, all right, and find the degree measure of the angle between the vectors. Got it. All right, so in component form, we have 6, -2 for vector u, and vector v's components are -3, 7. All right, we're asked to sketch or graph these vectors, so we'll go ahead and do so. 6, -2, I'm just going to make this 6 and maybe this -2. Plot a point, draw vector u. Vector v is -3, so maybe about right here, and +7 probably kind of up here. All right, and this is vector v. So if I had to kind of eyeball the angle between these two vectors, I would say that it's definitely obtuse, greater than 90 degrees, but less than 180 degrees. All right, so we've graphed the two vectors. Now let's find the degree measure of the angle between the vectors. All right, so that means if we're accessing this formula up here, we've got to find the dot product. All right, so we're going to multiply the x components, -18, and add it to the product of the y components, -14. The dot product, or the numerator, is going to be -32. Okay, let's go ahead and find each of the magnitudes. That means square root. So for vector u, 6 squared plus -2 squared. Well, it looks like 36 plus 4, or 40, square root of 40. All right, and for the purposes of what we're doing with the square root of 40, there's really no need to simplify it. We've got a calculator that'll handle that for us. All right, magnitude of vector v. -3 squared plus 7 squared. I'm running out of room to work down, so I'll go across. So that's 9 plus 49. So that'll be square root of 58. And again, I'm not going to worry about simplifying it because the calculator will take care of all that for me. All right, to find the angle theta, we're going to do an arc cosine, and we'll assemble this fraction. So we've got -32 as the dot product, and the 2 square roots multiplied. Okay, so let's go to our calculator. We have -32. Everything looks good. So to 3 decimal places, I'll record that degree measure angle. All right, and if I remember correctly, we predicted that by looking at our graph that we would have a degree measure between the two vectors that was greater than 90 but less than 180, and certainly that number of 131.634 degrees confirms that. All right, looking back at the question, did I answer all parts? Yes, I graphed, and I found the angle between the vectors. All right, for this next example, we're asked to find the dot product given the angle theta and the two magnitudes. So in order to do that, we can use an alternate form of this formula right here. So if we wanted to find the dot product, u dot v, all I would need to do is multiply cosine of theta by these two magnitudes right here. So that's what we call an alternate form. So if you wanted to write that alternate form down here, U dot V is going to equal, I'll put the magnitudes, the product of the magnitudes up front, and then the cosine theta behind it. All right, so coming back to our example, that's where we're asked to find is U dot V. We have theta and we have the two magnitudes, so let's just, I guess, assemble everything again into this alternate form. So U dot V will equal the two magnitudes, 9 times 36 times the cosine of 3 pi over 4. Well, I don't trust myself with that math, so let me find 9 times 36. Look like 324. I could change my mode to radians and find the cosine of 3 pi over 4. But I do know from the unit circle that 3 pi over 4 is in quadrant 2, and that x-coordinate is negative square root of 2 over 2. So no need to change to a decimal. So let's clean this up. We can put a 1 underneath 324. 2 will divide into 324, I think 162 times. So my answer is going to be negative 162 times the square root of 2. So I didn't know the components of vector u or v. That's okay. I can still find the dot product without knowing the individual components by using this alternate form of this formula right here that finds the angle between two vectors. All right, and our final objective is to look at what does it mean for two vectors to be orthogonal. Well, to be orthogonal, that's kind of a fancy word. All it means is that the vectors graph at right angles, because that's what perpendicular means. All right, it says look on page 576 for 5 possible orientations of two vectors. So I happen to have a copy of that page here. All right, I can see vector u going off in one direction, but vector v goes off in the opposite direction. So we're in opposite directions. The angle between these two vectors would be 180 degrees, or equivalent, an equivalent radian measure would be pi. So how would we get 180 degrees or pi? Well, that would be if we used our formula to find the angle between two vectors, and that fraction simplified to -1. Because if we remember on the unit circle over here at -1, okay, we do get 180 degrees from standard position. So if cosine of theta in our formula equals a simplified fraction of -1, that's going to tell us that we have two angles that are occurring in opposite directions. We can call those parallel. All right, let's look at what happens here. What happens when you graph two vectors and you have an obtuse angle, an angle greater than 90 but less than 180? Well, what that means is that the cosine of theta would be equal to, when we simplified our fraction, a negative number between -1 and 0. All right, let's revisit, because I think this may have happened before. Okay, how do we know if two vectors have an angle of 90 degrees between them? Well, we know that the cosine of theta is equal to 0. So when we simplify the fraction, we get 0, which really means that the dot product, u dot v, which is in the numerator of that formula, is equal to 0. So then we have orthogonal vectors. So right angles, 90 degrees. All right, two vectors when graphed may produce an angle between them that is acute. And what's going to tell us ahead of time that we have an acute angle between two vectors? Well, when we go to use the formula, cosine of theta will equal, when we simplify our fraction, a number that's positive between 0 and 1. All right, if you look at vector u and v, they're going in the same direction and they're also parallel. So how would we get parallel or vectors that are going in the same direction? Well, cosine of theta would have to exactly equal 1. And notice the angle between these two vectors is 0. That means they're going in the same direction. They're parallel. Okay, and then again, kind of comparing it with this other case over here, If we get a value in our fraction when simplified of -1 and not +1, well, the -1 means the vectors are going in opposite directions, but we'll still call those parallel. All right, do you have to memorize that? No. Okay, so let's go back to a couple more examples. All right, I'm going to pull the formula to find the angle between two vectors down here so it's closer. All right, the directions say, determine whether u and v are orthogonal, parallel, or neither. Notice that they didn't tell you to find the angle between the vectors. They're not going to specifically say that, but that's what you have to do. You have to find the angle between the two vectors to see if the answer is 90 degrees, which means you have orthogonal, or if the angle between them is either 0 degrees or 180 degrees to be parallel, or if it's neither one of those, 90 degrees, this is 90 degrees. Parallel means 180 degrees or 0 degrees. If we don't get one of those three answers, then the two vectors are either, the angle between them are either obtuse or acute. All right, so determining whether these vectors are orthogonal, parallel, or neither means that we need to use this formula right here. All right, if you want to write them in component form, since they're in linear combination form, that'd be fine. What do we have here? -1, -1. Okay, let's find the dot product. So that product is -2 and that product is 2. So -2 plus 2. So that's going to give us 0 in the numerator of this fraction. So it really doesn't matter what these magnitudes are going to be. We can go through the process of finding them anyway, just for the practice. So magnitude of vector u, square each component. That's going to be 4 plus 4 or 8, so that's square root of 8. Magnitude of v, square each of those components. So that'd be +1 plus +1 or square root of 2. Okay. So dot product is 0. It doesn't matter what the square root of 8 times the square root of 2 is, because this fraction will reduce to 0. And when you do a second cosine on that, you are going to get 90 degrees. So 90 degrees means that our angles occur at right angles, 90 degrees, whatever. So that's orthogonal. Okay, and a way to confirm that, if you wanted, you could graph each of these vectors and you would see that they occur, that the angle between them would be 90 degrees or orthogonal. So you could verify it with a graph. We weren't asked to do that, but we could. All right, so looking at vector u and v, are these orthogonal, parallel, or neither? Oh, we're already in component form, so let me find the dot product first. So 10 times -18 is -180, plus 20 times 9 is 180. Well, shoot, we might as well stop here, because no matter what these magnitudes are, who cares what the magnitudes are, we're still going to get 0 in our fraction. So theta equals arc cosine 0 for the dot product over the two magnitudes, which we don't care what numbers those are, because that fraction is still going to be 0. So arc cosine of 0 is going to give us 90 degrees. So we again have two vectors that cross at right angles, or the angle between them, I should say, is 90 degrees. So we'll use the word orthogonal. Again, you can graph these vectors and see that the angle between them is 90 degrees. All right. Let's find the angle between these two vectors so we can respond to the question. 15 times -5, 25, -75 plus -27. negative 102. Magnitude of u, 15 squared plus 9 squared. That, I think I've already done that, is square root of 306. And magnitude of v. Oh, I don't know why I'm cubing it. Let me square it. 25 plus 9 is 34. And we'll go to our calculator, and when we do that, we're actually going to get 180 degrees. So the angle between two vectors is 180 degrees. That means that we're going in the opposite direction from each other. That was our first case here. Here, 180 degrees. So that means that we will respond and say that these vectors are parallel. Okay, notice that I didn't do any examples where we didn't get orthogonal or parallel, but you would know that because you wouldn't get 90 degrees, you wouldn't get 180 degrees, or you wouldn't get 0 degrees. You'd either get an obtuse angle measure or an acute angle measure. All right, so in this video lesson, we were pretty much using the formula for finding the angle between two vectors, but sometimes we had to, for some of the questions, use an alternate form of that particular formula.